Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video we are going to continue studying perfect competition by analyzing perfectly competitive markets algebraically and graphically. We're going to use this to build out short-run supply functions for both a firm and the market, and then see how everything comes together with supply and demand in perfect competition. As with many of the other topics in this course, we can use three different methods to think about and study these topics: schedules, graphs, and equations. In the last video, we looked at profit maximization with a schedule. We're now going to turn to the equations and the graphs. However, I need to point out that when we move to the equations and graphs, we are no longer limited to integer values for prices and quantities. One way to think of this is that we are dealing with a good that is a liquid, like gasoline, for example, that can be poured out to any amount you want. For the equations that we need to represent perfectly competitive markets and the firms within them, I'm going to just give you the equations. The derivations of these equations require some calculus, so I'm not going to show you that now. I'll save that for a later course. Consider a perfectly competitive market that has 16 firms. I'm going to use N to denote the number of firms. All 16 firms are exactly the same. They have the exact same cost structure and they produce the exact same good. I'm going to use a lowercase q to denote the output of a representative firm. A representative firm is just one of our 16 firms, and they're all the same, so we're just going to look at one example firm. Our firm's marginal cost is given by the equation MC equals 10 plus 4Q. This is going to tell us the marginal cost at any possible output that we have. The average total cost equation is 50 over Q plus 10 plus 2Q. Recall that in perfect competition, we want to increase output if the price is greater than marginal cost. We want to decrease output if the price is less than marginal cost. If we can choose any quantity we want, then profit is maximized at the point where price equals marginal cost. We can therefore figure out how much output our firm is going to produce by setting our marginal cost of 10 plus 4Q equal to P and then solving for Q. I'll subtract 10 from both sides to get 4Q equals P minus 10, and then divide both sides by 4 to get Q equals P minus 10 over 4. We can then plug in any price we want, and that will tell us what is the profit maximizing quantity for our firm to produce. What we've just done is found the firm's supply function. Note that as with any supply function, there is a point at which this Q would drop into the negatives, and that's any price below 10. And so that's going to tell us our price axis intercept. Back in Chapter 4, we talked about the idea that the market supply curve is all of the individual supply curves added up. Since we have 16 identical firms, we can compute that from our firm supply function. So we'll have QS, and I'm going to use a capital Q to denote the whole market, is 16 times our small q, which is going to be 16 times P minus 10 over 4. 16 divided by 4 is 4, so we're going to get 4 times P minus 10. We'll multiply that out to get negative 40 plus 4P. I've just rearranged it so that it looks just like all of the other supply functions we have worked with. Now that we have the market supply curve, all we need to do is introduce the market demand curve, and that's going to allow us to solve for the equilibrium price and quantity in the market. Suppose our demand function is 360 minus 4P. To get our equilibrium, I'm going to set negative 40 plus 4P, our quantity supplied, equal to our quantity demanded, and then solve by adding 40 to both sides. It's going to give me 400 over here, and then adding 4P to both sides to get 8P over here, and then I'm going to divide both sides by 8 to get our equilibrium price of 50. This should look very familiar to what we did back in Chapter 4. We can then plug that 50 into either of our equations to get our equilibrium quantity. So I'll use the supply function, minus 40 plus 4 times 50. That's going to be negative 40 plus 200, which is 160. There are two ways to go about figuring out what each individual firm is doing. Remember that each firm will produce P minus 10 divided by 4 output. So if we plug in the price of 50, we get 50 minus 10 over 4, which is 40 over 4, 10. Alternatively, our market quantity is 160. We have 16 firms, so it has to be the case that each one will produce 10. Now that we've done all the algebra, let's draw the graphs. The best way to represent perfect competition is with two side-by-side graphs. On the left, I have the market graph, and on the right, I have a graph for a representative firm in the market. When I draw these, I always make sure that the price axis is scaled the same on both so that I can carry things horizontally across from one graph to the other. First, I'm going to graph our marginal cost function. Marginal cost was 10 plus 4q. That's going to start right here at 10 on the firm graph. For every quantity we go over, we need to go up by 4 price. It's going to look something like this. It's going to be a straight line moving upward. I'm going to draw in our average total cost curve. This is a little bit more complex to draw, and for the moment it's not important for you to understand exactly how this is done. But I do want to point out that the point where it crosses the marginal cost is its lowest point, which here happens at a quantity of 5. Over on the market side, we have a demand function, QD equals 360 minus 4P, and we're going to graph that in our usual way. We have quantity intercept of 360. 360 divided by 4 is 90, and that's going to be our price intercept. And we'll connect those up with a line. Our market supply, which we solved for earlier, was negative 40 plus 4P. To get the price axis intercept, note that 40 divided by 4 is 10. And so that's going to look something like this. Our equilibrium is a price of 50, quantity of 160, which we solved for earlier. To see how this market price affects each firm, what we're going to do is take our equilibrium price and we're going to continue drawing it all the way across to the firm graph. Since our firm can sell all the output it wants at that market price, the demand curve for each individual firm is going to be a horizontal line at the market price. Remember that the firm's marginal cost curve is also its supply curve. And so the point at which marginal cost crosses the firm demand, that is going to be the quantity each firm produces, which matches up with the 10 that we found earlier. The last thing that we want to do is calculate our firm's profit, which we define as total revenue minus total cost. We can actually see this on the graph by doing a little bit of clever algebra. I'm going to rewrite profit by rewriting total revenue as price times quantity and total cost as average total cost times quantity. I can then factor out the Q and get profit equals Q times price minus average total cost. This is an area that we can find on the graph. It is a rectangle. Quantity is 10, price is 50, and our corresponding average total cost is 35, which we can see from the graph. We can also plug 10 into the average total cost equation to get that. Recall that average total cost is 50 over Q plus 10 plus 2Q. Plugging 10 into that, we get 50 over 10 plus 10 plus 2 times 10. So we're going to get 5 plus 10 plus 20. That's going to be 35. So we can see that the height of this rectangle is price minus average total cost, and the base of this rectangle is Q, and so our profit is going to be this rectangle formed right here. To calculate that, we have profit equals 10 times 50 minus 35, which is going to be 10 times 15, or 150. Because price is greater than average total cost, our firm is making a positive profit, but had the average total cost been above the price at our profit maximizing point, then they would be taking a loss. The analysis that we just did definitely is one of the more complex things we've done so far, and it does rely on quite a bit of algebra and graphing these curves. What I mainly want you to understand is how the firm's decision-making process involving their marginal cost curve translates over to the market side for the market supply curve, and then how the market equilibrium goes back over to the firm side to figure out what is each firm going to do and what is the profit they are going to make. That is it for the short run. In the next video, we're going to move on to the long run.